Hey everyone, let's take a look at numbers 15 and 16 in section 2.4. They're just to choose the correct graph in each instance. We're given some information. The first one, number 15, I have up on the screen. Assume the function f is left continuous, but not continuous at x equal 2, and right continuous, but not continuous at x equal 3. Identify the graph of the function f. The way I've sort of proceeded with this is, first of all, we're told that it's not continuous at 2 and not continuous at 3. So let's just look at that point. Clearly, the graph of this first function is not continuous at 2 because the limit does not exist at 2, right? The limit from the left is 2. The limit from the right is 1, right? As we approach 2 from the left, we're staying at a height of 2, going right to that hole, right to that point rather. And from the right, we're approaching this hole, which has a y value of 1. So the limits from the left and right both exist but are not equal. It's not continuous at 2. Same thing here, it's not continuous at 3. Okay, so this is a potential answer for the question. Same thing here, we're not continuous at 2, we're not continuous at 3. Same thing here, we're not continuous at 2, not continuous at 3. But this one over here at 2 and 3, we're continuous, right? I mean, the function is continuous. There's no holes, no breaks in the graph, no vertical asymptotes, right? The value of the function at 2 is equal to the limit of the function at 2, and the same at 3. So this is not down here, not one of the choices, obviously. It's got to be one of these three. So of these three, which one is it? Well, first of all, let's look at x equal 2. We're not continuous at x equal 2, but we are left continuous. That means as we approach the function, so we approach 2, x equal 2, from the left side or from below, right? The limit, if you will, as x approaches 2 from the negative side is equal to the value of the function at that point. Okay, well, let's look at this graph here. At 2, what's the value of the function at 2? What is f of 2? F of 2 is, there's the point, 2, right? F of 2 is equal to 2. Okay, so what's the limit as we approach 2 from the negative side, from the left, from this direction, right? Well, the value is going right to what? This point, right? You know, if I plug in 1.9, I get 2. 1.99, I get 2. 1.999, I get 2, right? So my limit from the left is 2. So the limit from the left is 2. The value of the function is 2. This is left continuous. So this could be possible. This is left continuous at 2. Same thing here, right? The value of the function here, f of 2, is 1, and the limit as we approach 2 from the negative side is also 1. So this also could be a possibility. This one down here, what's the value of the function at 2? Well, the value of the function of 2 is 2, right? There's the point. But as we approach 2 from the left, here we are on the line, the graph of the function, we're getting closer and closer to the y coordinate of this hole here, which is 1 apparently. So the limit from the left is 1. The value of the function is 2. This is not left continuous. Okay, so we've eliminated this one. So we're down to the top two. Is it the left one or the right one? Well, we'll now use the fact that at 3, we are right continuous. Okay, and so right continuous meaning that the limit as we approach 2 from the positive side or from the right is equal to the value of the function at 3. Okay, well, if we go here to this one at 3, what's the value of the function at 3? It's 3. Here's the point, right? F of 3 is 3. What's the limit as we approach 3 from the positive side? Well, here's the graph for any value of x greater than 3. It looks like it's always 2, right? So the limit as x approaches 3 from the positive side is 2. So the limit from the right is 2, but the value of the function is 3. They're not equal, therefore it's not right continuous. Seems like this will have to be the case. Let's see if it's true. F of 3 is equal to 2, and the limit as we approach 3 from the positive side is 2. So this is our winner. Let's check our answer and make sure. Yay, we solved it. Next question. Okay, number 16 here. Similar, we have basically, I think, the same graphs maybe, or something very similar to the ones we had, but here's the information now. We assume that the limit as x approaches 1 from the positive side of the function and the limit as x approaches negative 1, 1 from the negative side, the limit from the right and from the left both exist and are equal to one another. So we've got to be basically going to the same point, right? Or same location, whole, whatever it is, from both sides. So here's important. Identify the graph of the function f, right, with this condition that is continuous except at x equal 1. Okay. Well, it turns out that that one statement really gives the answer away. So in other words, it's saying continuous except at x equal 1 means everywhere else other than x equal 1, it has to be continuous. Okay. Has to be continuous everywhere else. We'll take a look at this function here. It's clearly not continuous at 1 because we see the limit, although it exists and is equal to 1, it's not equal to the value of the function at 1, which is 3, right? F of 1 is 3, but the limit as x approaches 1 is 1. Okay, so it's not continuous at 1, but it's also not continuous at 2, right? The limit doesn't exist at 2, and it's not continuous at 3. So this can't be, continuous everywhere except for 1. All right, so it's not. So this can't be the case. Well, same thing here. We're discontinuous at 2. We're discontinuous at 3. Right here, we're discontinuous at 2, discontinuous at 3. So none of these three could possibly be continuous everywhere except x equal 1. The only one is this one. So it kind of gives it away, but let's just confirm this is true. What's the limit from the positive side as we approach 1, right? From the positive side, where are we going to? Right to this hole, and it has a y value that is something less than 1, maybe a half or something, I don't know. And as we approach 1 from the negative side, we're coming down here, we're going right to that hole as well. So right, both, we're going converging on that same location. It's not a break in the graph. And so the limit from the right and the left are both equal. So this is obviously the choice. Notice the limit from the right and the left on this one are both equal, right? So that does satisfy this condition, but the fact is it's not continuous, everywhere except for x equal 1. It's discontinuous at 2 and 3. This one here, the limit doesn't exist at 1, and that's because the limit from the left is 1, the limit from the right is 2, so it would not satisfy this requirement at all. This one does satisfy the requirement. It's continuous at 1, actually, and so it actually violates this statement really bad because it's continuous at 1, it's discontinuous at 2 and 3. Okay, so kind of a silly one in a sense when they put that statement in, but that is the correct choice based on that one statement. Let's make sure that I'm telling you the right thing. Yay, I think I am. Okay, I hope this is helpful for you on these last two.